This is my hairline. Harsh, I know it's receding quite a bit, but if we quickly put this on decimals, we model it, and there it's a function. We just turned my receding hairline into mathematics. Now let's determine how fast my hairline is receding using derivatives. Before we can do that, let's learn what is a derivative. Derivatives is how much a function changes with each coordinate. In simple, the slope. Take a look at this function. Y equals 2x plus 3. The slope is 2, and thus the derivative is 2 in this case. As with each change of an x coordinate, the y coordinate changes by 2. But what about my hairline function? Let's take a few seconds and try to see the derivative. Well, this is complicated because there is clearly a derivative as the y-coordinate changes with each x-coordinate, but it is so erratic. The reason for this is the function slope changes constantly with each step. For instance, at x-coordinate 1, the slope is 1.98. However, at x-coordinate 2, the slope is 0.8. The question is, how can you represent this? Well, brilliant people like Sir Isaac Newton discovered it by letting the derivative be represented as another function. Let's look back at our hairline function. Each x-coordinate has a separate slope. So what can we do to represent this derivative? Is use another Cartesian plane. Have the by making the y-axis be the slope and the x-axis be the x-coordinates of the main function, thus creating this graph and this derivative. For notation, people use an apostrophe, or formerly known as the prime, to represent a derivative. Here are some other forms of notation. The most common notation is dy dx, and if you're an IB student, it is recommended that you use this notation more often. However, this process of graphing is a very long process. Thus, other methods were created to find the derivative. These methods are called the power rule, chain rule, product rule, and quotient rule. Let's begin with the power rule, which is this. Essentially, we take down the exponent of x and multiply it with the coefficient and subtract the original exponent by 1. For instance, let's find the derivative of this example, y equals x cubed plus 2. For the first part, which is x to the power of 3, we bring down the 3 and then subtract the exponent by 1, giving the power of 2, resulting in 3x squared. And then for the next term, which is 2, because we don't see x there, but x is to the power of 0. And when bringing it down, 0 multiplied by anything just makes it 0. Thus, we can conclude that any constant like 2, 3, 4, 5, 6, 2 million will always be 0 when you're finding the derivative of it. Now it's your turn. Try to find the derivative of this function. Pause the video if you need more time. While this one was more tricky, here's the answer. Essentially, you need to know is that the first three terms, 3x squared plus 123x plus 2, was very straightforward power rule. You bring down the exponent, multiply the coefficient, and subtract the exponent by 1. However, the 2x to the power of negative 1 just makes everything negative because when you bring down negative 1, multiply by 2, it makes it negative 2. And negative 1 minus 1 is also negative 2, so the exponent is negative 2. The more trickiest part is noticing the square root of x can be written as x to the power of half, and then you can use your power rule from there. Let's look at another method, chain rule. This method is very specific and is meant for a binomial, polynomial inside a power, or a trigonomic. We'll look at trigonometry a bit later in this episode. Let's focus on binomials or polynomials for now. It works like this. We take the inside and we take its derivative and multiply it to the rest of the function. And then we bring the exponents down, or what we call the outside derivative. It sounds very complicated, I know. That's why let's look at this question. Find the derivative of y equals 2x minus 3 squared. Applying chain rule, we take the inside, which is 2x minus 3, and find its derivative, which is 2, following power rule. Then we multiply that outside. Then we bring down the exponent, or we do the outside's derivative. And the outside is just squared, so we bring down the exponent 2 and subtract the top by 1. This leads to 2 times 2 times 2x minus 3 to the power of 1. Then we just clean this up and we get 8x minus 12, or we can show it as 4 times 2x minus 3. Always show your notation. You would always lose marks on this. Now try this question for yourself. Feel free to pause the video if you need more time. Here's the answer. Just make sure you wrote out the proper notation. Instead of dy dx, you should have wrote f prime of x. Also, make sure whenever you come across a question like this, including chain rule, never do binomial expansion, as this will lose you marks on any assessment you do. Now, with this newfound knowledge of power rule and chain rule, let's tackle product rule. Product rule is used when two different terms are multiplying each other, like these ones. It works like this. Essentially, to derive y, we multiplied the derivative of the first term with the normal second term, and added with the derivative of the second term, multiplying the normal first term. Sounds really complicated. Let me show you an example. Find the derivative of f of x equals 3x squared plus 2 times x plus 1 cubed. The very first step we do is find the derivative of both terms. So the derivative of 3x squared plus 2 using power rule is just 6x. And the derivative of x plus 1 cubed, well, this one we need to use our chain rule. So we do the inside, let's take that out, we find its derivative, it's just 1. Then we bring down the exponent, 3, and then we do x plus 1 squared. Now that's the derivative of our second term. Now all we do is substitute everything in. So we multiply the derivative of the first term, which is 6x, with the normal second term, so x plus 1 cubed. Then we add this with the derivative of the second term, so our x plus 1 cubed, which is 3x plus 1 squared, and we multiply this with the normal first term, which is 3x squared plus 2. And then we can just leave it as it is. There's no need to factor. You can leave it just as it is. Now try out this question, and if you need more time, feel free to pause. Essentially, if you were able to notice, we can convert the square root to the power and a half, and then we can use chain rule to find its derivative and apply product rule. Product, chain, and power rule were very difficult concepts. But let me introduce you to your first real boss of calculus, which is our beloved quotient rule. To begin with, we use quotient rule when two different terms are dividing each other, like these ones. It works like this. Essentially, there are two terms, the numerator and the denominator. We first grab both of their derivatives, and then we plug it into the formula, which is the derivative of the first term multiplied by the normal of the first term minus the derivative of the second term times the normal of the first term divided by the derivative of the second term squared. Let me show you an example. Find the derivative of y equals 2x plus 1 divided by x cubed plus 7x. To solve this, let's find the derivative of the term. So the first term, which is our numerator, and thus 2x plus 1, its derivative is 2. And for the second term, which is our denominator, its derivative is 3x squared plus 7. Following power rule. With these, we can plug them into our formula, like this. And now all we do is clean up the numerator, and then we are done. Now it's your turn. Try out this question, pause the video if you need more time. Here's the answer. Just make sure you change the square root into an exponent and go from there. Now you should know how to derive with quotient rule, product rule, chain rule, and power rule. Obviously, you will need to practice this on your own time as this doesn't stick instantly. And this is kind of like the foundation of all of derivatives in calculus. Now here's a plot with twist time. We have been only dealing with plain old x and its buddies, the coefficients and the exponents, but now let's move on to something more difficult, like sine x and ln x. It is better if you actually memorize how it works rather than trying to understand it. Um, Even though some students will have access to the formula booklet, it's still better to memorize it because it's hard to flip through it in and out of the pages. So here is the formulas. It is also very important to know that for ln of x, its derivative is 1 over x, and it's only meant for the positive values of 1 over x, as ln x never has negative x value. Now try out these problems by yourself. Remember to pause the video on your own time, and here are the answers. Take your time, double check your steps. Heads up, question 2 and 3 were very sneaky. They hid the product rule and quotient rule, so hopefully you caught on to that. But all 3 questions had one thing in common. Chain rule was everywhere. Let's zoom in on question 1. So we've got the composition of sine of 3x and it's multiplied by 4. The inside function is 3x. The outside is sine x. Following chain rule, we take the derivative of the inside, which is 3, and multiply that by 4, giving us 12. Then we take the derivative of the outside, and the derivative of sine is cos following our memorization, and our final answer is 12 cos 3x.
Here is a quick flowchart to help you figure out which derivative root you should use. So when you see a crazy looking function, you will actually know where to start. And if your brain shuts down like me, when you see something crazy as like sine 3x times e to the power of x over x squared, don't worry, this flowchart will be your new best friend.
With this new ability to determine the derivative function, let's understand how we can use it. Well, we know that derivative's function, x-axis, is the x-axis of the original function, but the y-axis for the derivative's function is the slope for the original function. Thus meaning, if we wanted a slope at any time for the original function, we plug in the respective x-coordinate into the derivative function. This slope also represents the slope of a tangent line. A tangent line is a line that touches the curve at exactly one point, so the point of where you want the slope, and matches the direction of the spot. Sounds complicated, I know. Just think it as where the x coordinate is going and at what slope it's going at. On the other hand, a normal line is perpendicular to the tangent and passes through the point the tangent touches the curve. Let me show you an example. The question is, find the tangent line and the normal line of y equals x squared plus 5x at x equals 3. The first thing we do is find the derivative of y. We will use power rule in this case. And the derivative is 2x plus 5 because we bring down the exponent, we subtract the exponent by 1, and we multiply the exponents with its coefficients. Now we know that the tangent line slope is the same as the slope of at the x coordinate. And as the derivative tells us the slope, we will plug in 3 to the derivative, giving us 11. This is the slope of the tangent. We also know the tangent line touches the curve exactly once at x equals 3. So let's plug into x equals 3 into y, which gives us 24. So we just found the coordinates of y. Now we can plug in 324 into our tangent line to find the y-intercept. This gets us negative 9. Now let's find the normal. Normal is perpendicular to the tangent, so we do the inverse reciprocal of tangent slope, which is negative 1 over 11. With this, we plug in 324 and get the y-intercept as 267 over 11. Very annoying numbers, I know. Thus, our lines are y equals 11x minus 9 for tangent, and y equals negative 1 over 11x plus 267 over 11 for our normal. Now try out this problem. Find the normal and tangent line at x equals 1 when y equals sine 2x times square root of x minus 2. Remember, pause the video if you need more time. This is the answer. Please take the time to check over it. Pause the video if you would like. By now, you should have a solid grip on power rule, chain rule, product rule, quotient rule, trig, log, exponential, derivatives, tangents, and normals. Just make sure you keep practicing because this does not stick overnight. And I will see you guys in the next video.